What if the smartest AI wasn't locked away in the cloud, but could live right here, in your pocket? Well, some groundbreaking new research from Apple is making that a real possibility. They're totally rethinking a fundamental piece of AI, its memory. So let's break down how this all works.
Okay, quick question for you. When was Albert Einstein born? Just think about it for a second. For most of us, that answer just kind of pops into our heads, right? Our brains are incredible at pulling out one specific little fact from a whole lifetime of information.
But here's the thing. What's totally effortless for us is a huge headache for AI. For a large language model to remember millions and millions of simple facts like that, it has to get gigantic and use an insane amount of power. Honestly, it's one of the biggest roadblocks in AI today.
So let's start right there. Let's dig into AI's big memory problem.
You see, the way we usually build these things is like creating one single, massive brain. Every last thing the AI knows, from how to reason and write a poem, all the way down to Einstein's birthday, it's all just crammed together into what we call its parameters. The huge issue is that all of that information has to be loaded into memory all the time, even if you're just asking the simplest question.
In this approach, well, it leads to a ton of problems. The models get huge and sluggish, which is a big reason why having truly powerful AI on your phone is still so tough. It's super inefficient. You're basically loading an entire encyclopedia just to look up one word. And maybe the worst part, when the model learns new stuff, it can accidentally overwrite and forget older, rarer information. It's a problem with a pretty dramatic name: catastrophic forgetting.
So how in the world do you fix that? Well, Apple's researchers came up with this really elegant solution, and the best way to understand it with a simple analogy: a brain and a library. So, instead of one giant, clunky brain, this new model has two distinct parts. First, you've got a smaller, much more efficient anchor brain. Its job is to handle all the reasoning and common sense. Then you have a completely separate, massive memory library that stores all those specific, rarely used facts. And here is the genius part. The AI never tries to load the entire library at once. Nope. When you ask it a question, it just goes to the library, finds the one specific book or block of memory that it needs, and uses only that. It's a ridiculously efficient way to do things.
Okay, but you might be wondering, with a library that big, how does the AI find the right piece of information so quickly? Well, that's where their smart library system comes into play.
It uses a process called hierarchical retrieval, and it works exactly like you'd find a book in a real library. Let's say you ask about the element silicon. The AI doesn't just randomly search everywhere. It quickly goes to the science section, then down the chemistry aisle, over to the periodic table shelf, and bam, it pinpoints the exact memory block it needs. It's fast, it's clever, and it's built to handle tons of information.
This quote from the paper really hits the nail on the head. It explains why this is so powerful. Because the chemistry part of the memory only gets activated for chemistry questions, it's not getting messed with when you ask about, say, history or art. And that's exactly how the system stops that catastrophic forgetting we talked about. It protects the rare knowledge.
Now this all sounds fantastic in theory, right? But does it actually work in practice? Well, this is where the results get really exciting.
The researchers put these new models through their paces, and honestly, the performance gains they saw were just staggering. Get this, a tiny 160 million parameter model, once you pair it with this new memory system, performs pretty much identically to a standard model that's more than twice its size. Let that sink in. Less than half the size for the same overall performance. That's huge. But wait, it gets even better. That's just the overall score. The truly mind-blowing result comes when you test the model on its ability to recall those rare, obscure facts we mentioned earlier.
Just look at this chart. A massive 1.4 billion parameter model was only right about 17% of the time when asked for the atomic numbers of the rarest elements. Pretty bad, right? But when they added the memory system, its accuracy shot up to 83%. From 17% to 83%. That isn't just a small improvement, that's a complete game changer. So, what does this all mean for us? For the real world. This isn't just some academic paper. It's pointing to a future where powerful AI becomes truly personal. A future with AI right in your pocket. This kind of architecture could finally make powerful AI on our phones and laptops a practical reality. And think about the other benefits. Way better privacy, since your personal info could live in its own private memory library on your device. You could easily update or even delete specific facts without having to retrain the whole model from scratch. And of course, it's just massively more efficient. which saves a ton of energy and money.
Ultimately, this research asks us to imagine a totally new future for AI. A future where the most powerful intelligence isn't some far-off service in the cloud, but a private, efficient, and unbelievably capable tool that lives right here, with you, in your hand,